In this learning objective, we're going to discuss the conservation of energy for a closed system. A quick review of some terms and ideas we talked about before. Total energy, we defined as all the energy in a system at a given state, and it can be, in this class, we define it as being made up of internal energy, kinetic energy, and potential energy. With it further defined, the internal energy being the mass times the specific internal energy, the kinetic energy being 1/2 the mass times the velocity squared, and the potential energy being the mass times the acceleration due to gravity times the height. Also, when we talk about energy transfers, there are only two energy transfers we talk about. We talk about heat transfer, which we denote with the letter Q, and work with the letter W. And our sign convention is HIP to win, heat in positive, work in negative. So let's get started. So conservation of energy for a closed system. Here we have a system where we're going to say it has an initial state E1, that's the total energy at the initial state, and the final state is E2. So in this system, it's going to be a closed system. By a closed system, we mean that there's no mass can cross the boundary. So if no mass can change between the initial and final state, then we can say that the change in the property of the energy of this system is going to be the energy at state 2 minus the energy at state 1. That's going to give us our delta. Well, since no mass is changing, the only thing that can change is going to be energy. So we'll have a process that occurs. The process is what takes you from one state to the other. And in that process, we will have some heat transfer and some work occurring. All right. So we can state that the change of state for a closed system results entirely from the energy transfer. So therefore, that change in energy change of the property is equal to that energy transfer. So this is how we're going to develop our first law of thermodynamics. So because we said that energy transfer is going to be the because we said the energy transfer is going to be equal to that change in the energy state. And we said that change in energy state will just therefore be the change in each of the components of the total energy. Then we can rewrite this as the energy transfer is equal to the mass times all that specific total energy, the change in that specific total energy. This is equation 3.1 in the text, and this is what equation we will use when we use. Excuse me. This is the equation we'll use when we say that we're using the first law of thermodynamics for a closed system. Some notes to make about using this equation. First, sign convention for heat transfer and work. Remember, it is always going to be HIP to win, heat in positive, work in negative. And secondly, that when we talk about the work for a closed system, the nomenclature work 1, 2 there, that includes all forms of work. Now, that may seem obvious in this case, but when we get to talking about control volumes, you're going to see how that differs. So just to differentiate for your future notes, when you talk about control volumes for a closed system, work 1, 2, that's going to incorporate all the work going on in that process.